Hi there, my name is Roger Williams, and this is another series in the Congruent Light series, another video in the Congruent Light series of videos. This is about making pie charts, and this is more of a code focus, but you'll see how easy it is to make pie charts using Mathematica, and we're going to make a bunch of pie charts. So first, I have a graphic here that shows the fraction of arable land for Asia in coffee tones. You can see this is Asia. And so I guess it goes from 10% up to 100%. Now, I've changed the code here a little bit that invokes this, and I changed it to Europe. So let's run this. And ideally, it will show Europe, arable land, in a different set of colors, in beach colors. And here's our legend. So it's just interesting. It's using a random color set and different content each time. So just interesting. Now let's go to what we're going to cover. So stored data, curated data, was added in Mathematica version 6, and this is curated data from many types of objects, including cities, countries. We just had another one on French cities elevation with cities and countries, chemicals, astronomy, many others. Each object type has many properties, so it's sort of like a database of data. But instead of database commands, use the Mathematica API to access the data. And curated means that it has been reviewed for accuracy. So a human has looked at it and said this is accurate. And like so many things in Mathematica, it has very large volumes, a lot of data. So let's go ahead and jump in here. Now the first thing I want to talk about is an idiom, a coding idiom. And for this lesson, that's building pipelines. So when you read Mathematica code, you sometimes encounter what I call pipelines, and pipelines has a lot of different meanings. So I will see a graphic or result I like, and when I look at the code, it is basically all on one line with punctuation between lots of function calls. And there's one example on this page. I don't know where this page goes, okay? And as I've coded more and more, I've learned to build pipelines using the previous token. It's called previous, often. And this way you can test wrapping the previous output and produced by the previous input in a successive. Okay, good old Windows 7 right in the middle of everything. No, leave me alone. Okay. We use this idiom extensively in the presentation. And I did a help on %. So %n is a global object that is assigned to the value produced by the nth output line. % gives the last result generated, like the previous result. And % gives the result before the last. And % gives the kth previous result. So we'll look into this a little bit more. It may not be clear right now. So the boss says, I need a bunch of pie charts for that report due tomorrow. I'm telling you, you're just now telling me you need it by tomorrow? Give me some. Of what? Just use some relevant data. Just give me some pie charts. I got a report. So we use completion control K. We've talked about this before with country and see how many there are. And we use a previous token. So first I'm going to take away part of this and just start a country, and then I'm going to hit control K. And it's going to fill in country data for me. And so I'll get all the countries that our system has available to it. And I'll use a previous token, which will take what was in there and show me that there are 238 countries in our system, in the country data system. Now I want to see what some of them look like. Actually, I'm going to make this 8. And I'm going to use previous, which goes back to previous. And here are some: Afghanistan, Albania, they look like they're in alphabetical order, Bahamas, Bahrain. Then there's 206 of them in the middle, because there's 238 total. And then it goes to United States, Vanuatu, I've never heard of, the Western Sahara, Yemen, Zambia, and Zimbabwe. So this is a list, a shortened list of 8 lines roughly of the countries, of the 238 countries. And I want to see what attributes are stored for each country, so I just want a short list of the properties. I have a hint that there's a large number of properties, so I only want to look at some of them. So there's adult population, agricultural products, annual HIV/AIDS deaths. There's obviously a lot of properties. There's 200 and plus however many are here, so there's 220 or so properties. Unpaved airport lengths. Now obviously every country may not have reported every single one of these values. So let's move on. What about annual births? What is the annual births in China? Oh wow, look at that, a very large number, 1.7. So there's a lot of births in China every year, annually. 10 to the 7th, that's 10 million, I guess. So basically 17 million. And in France, one would expect there's many fewer, only 800,000. And is there a different attribute that I can put in a pie chart? Annual births would be one attribute. But then there's the ethnic groups fraction. We'll just try that out, of Armenia. And we can see that in Armenia, 97% are Armenian, 1.3% are Yazidi, 0.5% are Russian, and 0.3% are some other set of groups. So let's look at Azerbaijan. In Azerbaijan, 90% are Azeri, 2.2% are Dagestani, 1.8% are Russian, 1.5% of Armenian, from Armenia, which is nearby, and then there's 3.9% that fall in another category. Let's look at this just for grins. The United States, ethnic group fractions. United States. See how this looks, huh? 79% white, 12.8% black, 4.4% Asian, 0.9% Amerindian. It's interesting, Hispanic is in here. That's an interesting thing. But anyway, let's move on. Of course, I messed up percent. So let's go back. Oh no, we can do it with the United States data. I'm going to use a pie chart, and I'm going to grab those percentages. And it makes me a pie chart with no labels. Presumably this is white, and this is black, and this is Amerindian. So you can see how easy it is to make a pie chart based on the data here or here. I could get %10. Let's try %10. And that would be the data for Azerbaijan. A pie chart of the ethnic fractions data in Azerbaijan. So presumably this big amount here is Azeri, 90%. Okay.